Hello guys, today we are going to start to describe the logical operators and the function explanation in the C programming language. Okay, these two topics are included some function and examples today, and so in order to describe or learn the full mechanism in the C programming language, and so we need to create a new project. Okay, and so we should select these empty projects in here. We need to push the next button, and so this is our week 7 and then we should select the browse section in here with 7 select, and so the place solution and project in the same project should be checked, and so we can create the R projects or the empty projects in here. Okay, and so this is our editor, and we need to add the source file, the new item in here as a C++ file, but in the C programming language we should add the main.c blocks in here, because the extension is the description of which compiler is used to compile the whole program into the CPU code. Okay, and so this is the C programming language lesson, and so we need to select the .c extension form in here. Okay, and so we should test our program is okay, and so stdio.h should be added in here int main and return 0, and so printf week 7 is started with a new line character, and then if we run this program, and so the week 7 is started. Okay, and so what about our topics? Our topics is that the logical operators and the function or definition or declaration of it. Okay, and so if we need to start the operators, and then we should describe these operators into the two sections: bitwise operators and the logical comparison. Okay, because logical operator can be used in the if statement, for statements, or any keywords, creating a loop or comparison, but we can also use the logical operators in the numbers or the string character or the otherwise. Okay, and so firstly the bitwise operators should be discuss about it. And so what is the bitwise operator? Normally in the maths, for example, you should give some specific integer value like this one, a equals to 5. Okay, and so a or integer b is equal to what? The 8. Okay, and so in the computer structure or architecture, the whole types are stored in the CPU, or which we can use the RAM structure. Okay, generally RAM is used to store this kind of variables, but the CPU can also store these values as an inline function. Okay, you should remember that, inline. In order to get more knowledge about it, you should search on the internet or the Google. And so generally if we store any variable in our computer and then RAM is used, you should remember that. Okay, but every every variables is stored as like this one, 0 0 0 0 0 1 0 0. This is the 1 byte representation of the RAM structure. Okay, and so what about this? The every variables or the every change in our computer is coding like this one, the binary code. Okay, this is our binary code structure. And so if we are using this integer value in here in the C programming language, and so the compiler translate the whole the variables into the binary code like this one. And so the integer is a 4 byte. 4 byte represents the integer value, and so our program turns this variable into this one, 0 0 0 0 0 0 0 0. This is the 1 byte. And so if we copy off these things, second byte, third byte, and fourth byte, and so 4 can be coded in the binary code like this one. Okay, 2 over 0 2 over 1 times 0, and 2 over 2 times 1, which is equal to the 4. Okay, but this is the representation of the 4 value of integer. What about the second term? The 8 can be coded like this one. Because in math or in the logic circuits design lesson, you should define the whole integer value like this one. Okay, and so if we have this kind of information in here in the compiler structure, then we can also apply some specific functions or some specific operators on this kind of section, because the everything which is defined in the C programming language can be translated into the binary code, because the CPU only process the binary codes. Okay, and so what about the bitwise operators? Which is the bitwise operators? There are some specific operators in our C programming language like this one, and or, which is bitwise or, and XOR, bitwise complement or not operation, shift left and shift right. Okay, and so these operators can be applied on this section like this one. Okay, these are the main structure of this lesson, and so we can use 2 examples in order to explain the whole the characteristic behavior of the bitwise operator in C programming language. Okay, and so this is our example code in here, and then if we define an integer a in here like this one, 4, integer b like this one, b, and so we can create an output in here like this one. Integer results can be equal to what? A and b, or the ampersand operator. Okay, and so the results can be given by like this one, percentage d over result value. And so what's the output of this program? If you rerun this program, and then the result is that the what? The 0. Okay, this is not an option for our perspective, but if we use this program like this one, a and b, and so if we rerun this program, and then the result is also a 0. Okay, but you should remember that the AND operation gives us what? If we apply the AND operation in here, and so the general results is that it's the copy of these things, and so if we have this kind of information, because these parts cannot be changed in this notation, okay, and so the 0 and 0 gives a 0, 0 and 0 gives a 0, 1 and 0 in the maths gives us a 0, okay, but the 0 and 1 gives us a also 0, okay, and so the output results, which means that the A and B gives us the 0 value, okay, and so we can translate into this code like this one, and so if we rerun this program in the AND operation, we have the 0 value in the output session. But we have also another operator, A and B is, okay, percentage D A and B, or, okay. This is the representation of the OR operation. In the OR operation, we can copy of these things and move to this session. In the OR operation, our codes can gives us the 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0 0. Okay, but what about this? In the maths or the logical operation rules, the 0 or 1 gives us a 1, okay, and so 1 or 0 gives us also a 1, but 0 0 gives us what? The 0, okay. This is the representation of the naive number in the integer type of this value, okay. And so the binary code gives us 1 1 value, and so this is the representation of the 4. This is also indicating a 8 value, and so the result of this code is 12, okay. This is the OR operation of this summation, okay. And so you have learned how to use the bitwise operators in here, but what about in this code? Printf A XOR B is equal to what? This one, okay. A XOR B, okay. And so what's the result of this code? And so if we rerun this program, and then we also a 12 value in here, okay. But the XOR characteristics gives us to what? To this one, okay. Because in the XOR operation, if the number 1 is the reverse of the number 2, gives us the 1 value, okay. But in the OR operation, the only 1 value is included in the 1 number, and so this is the sufficient condition to giving the 1 value in the output session, okay. And so what about this? The printf A or not A is to what? And so this is the complementary operation in here. And so if you don't know how this code behave, and so you need to test it, because in programming language we need to use this operation, okay. But In the terminology, the A is equal to this one, okay? And so the complementary operation gives us 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 0 1 1 value. What about this? This is the higher number of the integer value, but in the compiler section, the compiler sees that code in the negative notation, because in the maths, the every rule cannot be perceived or cannot be evaluated in the mathematical rules, okay? And so we cannot convert every rule into the compiler or the programming language, and so we need to code the minus value of any integer value, because the integer value has the negative and the positive value of this session. And so if we have this kind of information in here, and so these codes gives us a negative value of the integer representation, okay? And so what about this? Printf, the bitwise operator in the shift left usage, gives us what? Look at this, the bitwise operators in here, like this one. And so if we have A is B is equal to what? Percentage D. And so if we have this A number in here, or X number should be defined in this position, int X is equal to the 0 or 1, and int Y is equal to the what? The 2, okay? And so X, Y should be given in here, and so X bitwise left is equal to the what? Y, okay? And so if we rerun this program, and then the expectation of this character, okay, and so X shift left, the bitwise operator under the Y is equal to the what? The 4 value. What about this? And so in order to emulate, or in order to debug your program to understand how to behave like this, you should change the whole variable notation like this one. If we put the Y value in here is equal to the 0, and then the X is equal to the what? The 1. Okay. And so this is the 1 byte representation notation in here, like this one. And so this is not compiler rule. The editor gives us a definition of this value of integer. You should remember that the embedded software should give a compiler error if you are defining the new integer or double value after the sum using the printf function, okay? This is important, that, but in our session it's not important, okay? And so if we assign the X is equal to the 1 and Y equal to the 0, this X value does not shift it, because the Y is equal to the 0, but the Y is equal to the 1, or in the simple example we should select this code like this one. 1 left shifted operation is applied on the X value, and so this gives us what? 0 0 0 0 0 0 1. And so this is the first process in here, but in the second stage 0 0 0 0 0 1 0, and this is equal to the what? Equal to the 2 value in the integer type of this value. Okay, and so x is equal to the what? Is equal to the 2. Okay, and so printf function in here, new line. Okay, and then we have obtained this kind of information in here. But if we select the 2 in here, or 3, okay, and so we have the 8 value. If we select the 5 in here, and so we have the 32 value. Okay, and so if we have this notation 26, and so we have this kind of value in here. And so what about this bit notation? If we have 32 bits, and so if we rerun this program, and then the 32 what is equal to the 1. Okay, and so what's the meaning of this? And so in this session, the integer has a 4-byte notation in here, and so 4 byte consists of the 32 bits. And so if you shift the whole x value by the 32 shift notation, and so we got the same number in this value of this session. And so if we get the 32 and 33, and so if we rerun this program, and then the x is equal to the what? Is equal to the 2. Okay, and so what about this? This is the other example of this session. We obtain the general rules of the compiler by using this kind of example. And so if you don't know any knowledge or some knowledge in the C programming language, you can create a abstract example like this one in order to understand the underlying mechanism of how the compiler runs on or works on this notation. Okay, and so we have this kind of information. But if we have like this one, the integer y value is equal to the what? Equal to the 4. Okay, and so the y right shift operation in here, %d, and so y1, which is equal to the what? Which is equal to the 2. Okay, and so if we have 2 value in here like this one, and so this gives us a 1 value. If we have 3 value in here, and so 0. But what about the 4 value? The 4 value is equal to the 0. Okay, 5 value is equal to the 0. 6 value is equal to the 0. Okay, because every bit is turned into the what? Into the 0. But 32 or 33 value gives us also a 4 value in this section. Okay, these are the general basis for the bitwise operator representation, and this gives us the integer value of these things. But what about the double value? Double a is equal to the what? 4.1. Okay, and so printf the a value or the a shift bitwise operator is equal to the what? %d. And so if we have this kind of binary notation in here, and then the a is also defined in here, z is equal to the what? This one, because we should give the other notation. And so the compiler tells us this one. Expression must have integral type or the collective type, or we can interpret this error value in here. You cannot use the bitwise operation on the what on the types except the integer value. Okay, and so we cannot use the bitwise operator on the float value or string value or double value, but we can use the char characters because the char can automatically be transformed into the integer value. Okay, and so the bitwise operator is only related to the what to the integer value of this notation. Okay, these are the first session of our example lesson, and so we need to move up to what, to the logical comparison operation in the C programming language. Okay, now we should describe the logical comparison operators in the C programming language. There are three elements or atoms to describe the whole mechanism. Okay, which means that we have the AND, we have the OR, we have the NOT operator in the logical comparison. These operators gives us a only 1 and a 0 value in order to compare any logical statement. Okay, and so this logical comparison is explicitly used in what, in the if, for, or while, or do while. Keywords. Okay, because this is the loop and comparison structure of the C programming language, and so if we have this kind of information, and so we also a condition. Okay, in these statements the for is run until the condition is false or true. The while is run and or works until the condition is false. If gives us a true statement, if and else value, and so if notation within the parentheses is the correct or true, and then the first section is selected, but it is false, and then the else section is processed by the compiler. Okay, and so in order to learn these things, and then we need to create a specific example on these diagrams. Okay, and so we need to remove the whole things in here like this one, and so the x1 is commented on this section, and so the x2 is only related to the what, the usage of the logical comparison. Okay, and so we need to add the include value in here, which is used to what, to using the printf or scanf function in the main function body. Okay, and return 0 is added, should be in here. Okay, and so what about this? Again, we need to create a int a value in here and int b value in here too. Okay, and so if we define a result value in this session, and so a and b can give us a what? A result of this session. And so in order to see the result of this session, result is equal to the what? Equal to the this one. Okay? And so if we rerun this program, and then we have the result is 1. Okay. And so this gives us a 1 value of this session. But if we turn the b is equal to the 0, and then we have the result as equal to the what? The 0. Okay. And so this is equal to the 1, this is equal to the 0, and then the result returns to 0 value, like the bitwise operator session. But in this session we can use the 6 and 7 value in here, but the result only gives us a 1 and a 0 value. Okay? And so this terms returns only the 1 and 0 value. But in the usage of the bitwise operators, we can have also a non-0 and non-1 value. Okay? This is considered as the logical comparison, because if it is okay, or if it is equal to the 1, and so the loop works, or the if condition is true, and then the sum code is processed by the compiler. Okay, this is the main structure of this body. And so if you have this kind of information in here, and so a and b can be represented by this session, and the result is 1 until the b equal to the 0. Okay, result is 0. And so what about this? The printf, the result %d is equal to what? A or b. What about this? This is equal to the what? In the first place, b equal to the 0 gives us a 0 with the operation of the AND in here. Okay, but if we are using the OR operation in the logical comparison one, and so we may have the 1 value in here until the a equal to the 0 in this session. Okay, and so these loops can be used in the if and for and any loop structure in the C programming language. Okay, and so if we have this kind of information in here, a result %d new line 1 and 0 can be added in here. And so if we rerun this program, the result is 1, and so we don't need to use any integer value in order to use use the logical comparison in the C programming language. Okay, and so if you have this kind of information in here, and so result %d again is added in here, and so what if you have the 1 and 0 value in here, but with the same difference? The NOT operator is added in here. Okay, and so if we rerun this program, and then the result is equal to the 1, but in the previous stage we obtain to what? To 0. The NOT is used to what? To turn to 0 into the 1 value, or 1 into the 0 value in the C programming language. Okay, and so what about the nested logical comparison types, which means that the printf results in here, the 1 and 3 is selected in this session, and so %d is equal to the what? Equal to the this one. And so if we have this kind of A and B operation in here, and then we can also OR session with the NOT operator like this one. And so this is the compiler error or not. You should remember that if we have the provide the whole the language syntax rule, and so we don't have any error in the completion time, okay, or the compile time. If we rerun this program, and then we can also add additionally one value in this session, because in the first place the program or the compiler solves the parenthesis operation like this way, A and B. A and B gives us a 1. This is 1, okay? And so 1 and 0 gives us a 1 value in here, a 0 value in here. But if we have the NOT operation in here, and so this gives us a 1 value. And so this gives us a 0 value, but we have used the OR operation in here, and so 0 or 1 is equal to the what? To 1. But what about this? If we have this kind of information like this one, if we rerun this program, and then this terms is equal to the 0, this terms is equal to the 1, and the output result is equal to the what? The 0 value in this notation, okay? And so what's the importance of using this logical comparison in the C programming language? The important point is that, like this one, if we have new example in here like this one, int main should be added as a start address of our programs. And so integer A is equal to the 5, integer B is equal to the 4, and so if we are using the if statement in here, A is equal to the what? B, and so printf A is equal to B, okay? These are statements in here. But if this is not true, and then the printf should be equal to the what? A is not equal to B, okay? New line should be added in this stage. And so if we rerun this program, and then A is not equal to the B, but how the compiler tell us? By using the logical comparison, okay? This is the only return value of the 1 and 0 in this notation, because the equal notation gives us a 1 or 0 value, okay? But if you are using this stage like this one, you can understand the mechanism of this. But if we have this kind of information is given in here like this one, 1 is added to the parentheses of the if condition. And so if you rerun this program, then there is no syntax error in here, and so the program is output what? The A is equal to the B in the second if session. Okay, this is not a syntax error, but how? The program or the C programming language or the compiler, its compiler, add the some specific codes in here in the hidden structure, okay? And so if you have this one number in here, and so the compiler adds this condition at this position, okay? Because the compiler only knows this condition is true or equal to 0, or this condition is false or not, okay? And so in the uppercase, the A is equal to the B is not equal to the 0 gives us the same results with the previous one. Okay, A is not equal to the B is also applied in this session because this session is true, and so it returns to 1 value. And then if we have this kind of information in here, and so the compiler adds these codes in here in order to compare this session, and so this gives us a 1 value, and 1 is not equal to 0, and so this code is run on the program. Okay, and so what about the nested logical comparison operation? If we have the A is equal to the B, and so AND operation can be also add in here, and then we can add the sum structure 1 or 0 in here. This is correct. This is complex. It seems a complex code, but it's not, because the rule is simple. And so the printf function in here, the A is equal to the, or this section can be copied by using these things. And so if you rerun this program, and then the A is not equal to the B in this session. Okay, but how? In the first place, this code interprets by the compiler as a 1 code in the first place. Okay, and so the compiler check if there is any parentheses in here, like this one, and so the compiler tells you that I'm gonna start with these codes and these codes to process. Okay, and so 1 or 0 gives us what? 1 value. Okay, but A equal B value gives us what? A 0 value in here, because the A 5, B 4. Okay, and so this condition is necessary or not. In this stage it's not necessary. Okay, because we know it is gives us only a 1 value, but the compiler at the end of this stage adds this notation not equal to the 0 in the hidden or the secret code stage. Okay, and so if we rerun this program, then A is not equal to the B in this session. But if we change the A value in here, if we rerun this program, and then and then we have also A is equal to the B notation in here. Okay, and so we can create another example, and int x equal to the 3, int y equal to the 4, int z is equal to the 12 or 20 in the y or y notation. And so we can compare these things by using one statement in the C programming language, like this one. If x greater than or smaller than y, and the y greater than z, and so the process can be started. Printf, the process can be started in here, else process cannot be started in this notation. Okay, these are the code of representation of these things. And so the process can be started is the output of this program. Okay, because in this notation, okay, we should also clear this session in here like this one. Okay. Okay. And so if you rerun this program, and then the end int x, y, and z can be compared in the one statement session like this one. Integer a is equal to the what, equal to the 5, for example. Integer b is equal to the what, the 4 in here. Integer c is equal to the 30 or 23. And so if we parentheses these things in here like this one, and end session in here, and so we can give a new parenthesis at this session, a greater than b, and is satisfied, and the c greater than b can also be added in this session. And so if you rerun this program, and then the process can be started, because the whole condition is equal to the what is equal to the 1, or it's true. Okay, and so we can add these terms in the if position, and so the compiler also add this notation is not equal to 0 or not. Okay, and so we can copy all these codes by using where the for loop. Okay, integer I is equal to the 0, and so this condition can be copied in this one, and then the printf, the for loop can be added in here. And so if we rerun this program, and then the endless loop is started by the program. Okay, because this condition in every time true, because e is not changed in this diagram, and so the compiler also gives us a 0 value in here. Okay, so if we rerun this program, and then the for loop is going to the infinity, but assume that the y is, or the b is changed with I value in here. And so if we rerun this program, and then 1 2 3 4 5, and this is our for loop session in here, and %d can be added in this notation. And so if we rerun this program, and so 22 for loop is processed by the program, but the c is not greater than I, this statement gives us a what? A 0 value. And so 0 is not equal to 0, is not true, and then the program is ended, because the c is equal to what? 23. And so if we change this c value with the 43, and so we have also a 43 for loop value like this one. Okay, these are the usage of the logical comparison operation in the C programming language, and so you can drive the many example session by hand. But in order to understand the rules in the compiler section, you need to check these conditions like me. Okay, these are total rule in the C programming language, and so now we should move to what? To start the explanation of the function body or the function design in the C programming language. These are the last topic of our lesson today, and so we need to learn about it in order to use the C programming language efficiently. Okay, and so the last topic is the function. And what's the function? The function means that in the C programming language, collect the codes for a one specific purpose. And so the function summarizes the whole the codes in order to run these codes, like this one. Int main is a function. And so what's the purpose of this? The purpose of the main function is that to run the complete program in your architecture. Okay? And so if you have some specific purpose, for example, the calculation of the summation or the negation or the multiplying two integers and doubles, and you can summarize the whole the code as a one function. And so the function comes with the advantage of these things. Okay, advantage of function. And so the advantage of function, the collect the, or not a collect, the purpose of some codes like this one, sum, divide, or generate number, or control satellite, blah blah blah. Okay, and so you can read easily the code in the function blocks, because each function represents the some main body and with the purpose, and so you can easily transfer any codes into the other one. Okay, and so you can scale the full code into the another project. Okay, you can use it like this library standard input output H. This library includes the many function blocks to be used into the another projects with a specific purpose. Okay, and so if we have the functions and function definitions, and so we can easily translate these codes into the another projects, and so you can use it anywhere, which is the basis of the C programming language. Okay, and so what about the syntax of these things? Because in the C programming language, everything has a syntax and semantics. Okay, these two topics is or are included in everywhere in the C programming language. Okay, and so the syntax is the language rules, the semantics it's a process or the how to use it in the coding techniques. Okay, the syntax can be given by this one, the return value or return type of function and the function name, and we need to create these parentheses blocks in here, and so the return type, the function name, and so we have the arguments or the parameters of our function block. Assume that we have this kind of function. F is equal to what? X square plus 5. And so these are the function, because we can give this function the parameter as the x value with a different value of it. Okay, and so we have the output value in the end of this function, and so in the programming language it's similar with the maths. Okay, and so in the syntax rule the function should have a name with the specific notation, like the main function. The main function means that in the compiler section, the address of the starting point of your code, okay? And so we can give the arguments or the some parameters like the x value or the 5 value in this notation. And so this function produces the what? A result or the output with the specific type of this notation, okay? This is the our main syntax rule of our function declaration. And so in order to understand the clear meaning of the function usage, and so we can also create an example session in this lesson like this one, x5. And so in order to create some specific function in here, we should describe the name of it like this one, print hello in here, okay? This is the name of function, but we should give us the open and close parenthesis session in here. And so every function needs a return type of it. And so if you don't return any points of the function, you should describe the void, the unknown parameter in here. The void means that the typeless of this session, okay? And so you need to give the some main body block with the parentheses like this one, and so fancy parentheses in here, and then you can create the function body by using this notation, okay? And so if we run this program, and then there is no syntax error in here, and so this definition is true, okay? And so this is the meaning of the definition of a function block. But you can see that the function body can be written like this one. And so in the some codes, the void prints hello can be given by using this syntax. And so if we rerun this program, and then there is no error as well in here. But what about this? There are two definition or the two type of the function in the C programming language. A function can be declared by the usage like this one. And so if you are using this notation, or if you write these codes in here with the without the main body, and so this is called the function declaration. And so if we have using the fancy parentheses in here, and so this is also a function definition in the coding techniques, okay? Because everything in the C programming language is started but by where the main function body. And so if we call these function blocks in here, the print hello can be called by using this notation. We should name the print hello, and so we should add the function calling operator in C programming language, okay? Because the open and close parentheses call this address notation in here. In the advanced topics, it means that the address can be accessible by using the function calling operator in here, okay? And so if we rerun this program, and then there is nothing in the output session, but there is no error, the syntax error in our code. And so how can we fill our print hello function? And so we can use the printf function in here like this one, hello world, okay, with a new line character. And so if we run this program, and then we have the output of this string character as a hello world, okay? And so what about this? if we have using this syntax in here like this one, and so we can use the print hello. But in the C programming language, if we have comment on this session, and so if we rerun this program, and then there is syntax error in here because the compiler tells us the print hello read definition, different basic types in here. And so what does that mean? It means that you should declare the function block until the program goes to the main function, because in the C programming language every code is run on the what up through the down. And so firstly this code is implemented by the compiler, and so in the next session the main is implemented or run. And so in the main function block body the print hello should be called, but the print hello is not declared in this notation. Okay, and so the compiler tells us you should declare this function body, okay, because the print hello is at the bottom of the main function body. And so there are two options in here. Either we should move the print hello function in here, which means that there's no syntax error in here, or you should declare the function body like this one in order to use the print hello function. This is a simple example, but the printf function body is also declared in the standard notation of this library like this one, okay. Standard input output.h includes the printf function like this one. And so this is the declaration of what? Of the printf function body. And so at each time we can use this analogy because the standard input output session is included at the top of our coding techniques, okay. And so these are the basic notation of our function body. And so we can declare the function like this one. And so what about this? What about the parameter arguments in the print hello function body? Integer a, integer b and integer c can be added in here, okay. But we should also write this integer a, integer b and integer c in the definition of the function, okay. But if we rerun this program, and then there's syntax error because print hello 2 fifth arguments for call. This okay, this is okay, but the print hello should have the sum structure int a, int b and int c. And so for example 1, 2, 3 can be given to the parameter to what? To print hello function. And so if we rerun this program, and then the hello world is written on the output session. And so here is the question, is that the a and b is given to the print hello function, but we don't use it. There is no syntax error in here, but the semantics one, because if we are using this integer a, b and c value, and so you may use the these variables on this print hello function. But if you don't use this notation, and then there is no syntax error in here. But if you add some session %d, %d with the parameter of a, b, c in the printf function, and so if you rerun this program, and then hello world 1, 2, 3 is written on the output session. And so print hello can be called by the different parameter notation like this one. And so you can use the different arguments, but the type is always the same with the previous one, okay. And so you get the different output session in this notation, okay. These are the first example in here. What is the function definition and declaration in here, and how can we use it in the C programming language. In the second example, we try to create a summation or multiplication operation in the function declaration blocks. For example, if you have the two integer value like this one, integer a and integer b in here, and so the user can be asked by this one, please give two numbers in here like this one, and so scanf as can be used to store these variables like this one, ampersand a ampersand b, or the address of the a and address of b can be asked for or from the users. Okay, and so what about this? If we have the sum function in here, and then we can produce a sum notation in our coding techniques, because the printf function can gives us as the sum of two numbers can be given by %d new line characters in here, and so the sum should be defined by like this one, a and b. Okay, and so how can we define this function? First, we should declare this function block like this one. For example, in the first place, we should remember that every function should have the return type. In this case, the return type into what the %d is given by the integer value, and so we should write the integer in the first place, because we need to obtain the integer value at the output of this program. And so the function name is the sum. Okay, sum. Okay, sum x can be written in here, and so you can also write the Mahmud as a function block, but you don't need to use because it's not meaningless. And so the sum x should be given in here, and so in the usage, the sum x sum x needs two parameters with the type of the integer a and integer b, or integer x and integer y, because this name and this name may be different with this one, because it's the parameter, it's the temporary variable for our usage in C programming language. Okay, and so sum x function declaration can be declared by using this notation. Okay, but we should create a function definition blocks in here, function definition. Okay, and so in the main code or the main body, we give the two number with integer type of these things, and so the sum x takes these numbers a and b, and so produces the integer value returning to this variable. Okay, and so integer results can be defined in the function body, and so the result is equal to the x plus y, and so return value is equal to the result value in this notation. And so we can add the two variable in here, x plus y, the result stores it, and the result value returns to to this value. Okay, and so if we rerun this program and then give two numbers in here, 5 and 7, and we should put the enter button in here, and so the sum of two number is equal to the 12 in this notation. And so our function can be used in anywhere with this definition and with this declaration. Okay, And with the same syntax, we can use the negation or subtraction, sub x. And so we should only make the different from the sum block opcode. Okay, and so we should also give the int sub x notation in here, int x and int y in here in the declaration notation. And so the printf should add in here subtraction of two numbers is equal to the what, the sub x. Okay, and so if we rerun this program, and then there is nothing error in here, and so 5 7 can also 5 9 can also be given in here. And so the sum of two numbers is equal to the 14, and subtraction of two numbers -4. Okay, -4 in the position. And so we can create a lot of function definition in order to obtain or create some specific purpose by using these notations. Okay, these are the function session in here. Function session is an advanced topic in C programming language, and so these are the last summation for our program. And so maybe in the next lesson we will describe it too well by using or creating the header file and source file codes, because the standard input output.h is a header file, and so the source file as well as should be implemented on the C programming language. And so if you are a programmer, and then you can create a standard library or source code in order to use in the other projects. Okay, these are the last session of our programming language. I hope you learn about everything in the C programming language what I'm talking in this lesson. And so have a goodbye.